Hello students, welcome to the next part in the properties of the lubricant. We have discussed the viscosity index, flash and the fire point properties. Now we move to the other properties of the lubricant. In this lecture we are going to cover these properties of the lubricant like cloud and the pour point, which is also the important property of the lubricant in the selection of the lubricant. The next property we will cover aniline point and then the steam emulsion number. What is the learning outcome of the lecture? Students will be able to understand about the major properties like cloud and pour point of the lubricant, aniline point of the lubricant, and the steam emulsification number, which helps them to select the lubricant for the desired application. What is the cloud point of the lubricant? It is the minimum temperature at which the lubricating oil becomes cloudy or hazy in appearance. The temperature at which the appearance of the lubricant becomes cloudy or hazy is called cloud point. It is due to the presence of wax-like impurities in the lubricant. On cooling down the lubricant, the wax impurity separates out, which makes the lubricant cloudy or hazy. So that minimum temperature is recorded as cloud point. What is the pour point of the lubricant? The pour point of the lubricant is described as the minimum temperature or the lowest temperature at which the oil ceases to flow. What is the meaning ceases to flow? Means stops flowing, or we can say starts to freeze. So that minimum temperature at which the oil stops flowing or it starts for freezing, so that minimum temperature is recorded as the pour point of the lubricant. So the cloud and pour point is the range of the minimum temperature at which the oil stop flowing. So it starts from the cloud point and ends with the pour point. What is the significance of the cloud and the pour point of the lubricant? The cloud and the pour point of the lubricant indicate the suitability of the lubricants in the cold conditions. For example, in India, the northern area is having the cold climate where the temperature is low, and there we are using the machine in which we are using the lubricant. So in that condition, we should know the lubricant cloud and the pour point. The lubricants working at the low temperature should possess the low cloud and pour point. Whatever the temperature at which we are working on the machine and we have used the lubricants. So with that temperature, the lubricant should possesses the low cloud and pour point. Otherwise, the solidification of the lubricant takes place, which causes the jamming of the machine. If the cloud and pour point matches the temperature we are working on, the solidification takes place because it ceases to flow. That's the pour point, and it become solidify, and which will result to the jamming of the machine. So it is very necessary to know the cloud and pour point of the lubricant when we are using the lubricant in the machines working at the low temperature, like refrigerants, air conditioners. These are the major application where the machine works at the low temperature. So if we are using the lubricant in these machines, we should know its cloud and pour point. As well as in the cold climate conditions are there, where the temperature is always low. So we should know the cloud and pour point of the lubricant before using in the application. So that's the main significance of the cloud and the pour point. The cloud and pour point property can be determined with the help of the apparatus known as cloud and the pour point apparatus. It is very easy to remember that cloud and pour point can be determined by the apparatus, which is called as same as the property name, that is cloud and pour point apparatus. It consists of the flat bottom tube, which is also called test jar, and in this we take the oil sample to which the cloud and pour point should be determined, and the cork is fixed in this test jar through which the thermometer is attached. So this is the first part of the apparatus, that is flat bottom tube or the test jar, in which we take our oil sample and the thermometer to record the temperature. And this flat bottom tube is put in the another jar that is called that is empty, that is air jacket. So this flat bottom tube then put into the air jacket, because always when we cool down the temperature or when we heat the temperature of the lubricant, we always go for the indirect heating or indirect cooling. As you have seen in other properties like flash and fire point, we have the apparatus Penske Martin and Abel apparatus. In that also we have the air jacket, water jacket, which slow down the increase of the temperature as well as slow down the decrease in the temperature. Always indirect heating and indirect cooling can be done to measure the accurate results. So here also the flat bottom tube, which is put in the air jacket, and finally it is put into another large jacket in which the freezing mixture is taken, because we have to cool down the temperature. So what's the freezing mixture used? Ice and salt freezing mixture is used. So this is finally put in the another test jar where the freezing mixture is taken and it acts as the cooling bath. The temperature starts falling when you keep your lubricant in this. So when the temperature starts falling, you just every 1 degree or every 2 degree fall of the temperature recorded with the thermometer, you just take out your test jar or the flat bottom tube to see the cloudy appearance or the hazy appearance of the lubricant. So first you record that temperature at which cloudy or hazy appearance you should be observed in the test jar. If no cloudiness is appeared, you put your test jar immediately in the jacket in the freezing mixture. So the result should be observed by always observing the flat bottom tube and just see it and put it back. So after the measurement of the cloud point, we can again go to the pour point determination. The cooling should be continued for the pour point, and that minimum temperature at which the movement of the oil stops, and that you can observe by tilting your flat bottom tube. When you tilt your flat bottom tube, You just see the movement of the oil. If the movement of the lubricating oil stops, that will be recorded as the pour point. So these are the simple steps we can perform in the cloud and pour point apparatus and measure the cloud and pour point of the lubricant. So all the working steps, as I have told you, these are written here. The cloud and pour point apparatus consist of the flat bottom tube, air jacket and the cooling bath. The oil is filled up to the mark inside the flat bottom tube and fitted with a cork into which the thermometer is inserted. The tube is kept in the cooling air jacket surrounded by cooling bath containing the cooling mixture. The temperature of the oil start falling down. So when you put your sample and fix the thermometer and put it the air jacket and finally in the cooling bath, your temperature starts falling down. After every 1 degree centigrade fall in the temperature, the test jar is taken out from the jacket and inspect for the cloudiness. If no cloudiness appear, it is immediately put in the jacket, and this to be done in very few seconds. The cooling is continued and the tube is taken out after every 3-degree fall of the temperature and tilted just enough to see any movement or the flow of the oil. The test is continued until no movement of the oil is observed and that temperature is recorded as the pour point. So after the measurement of the cloud point, we should go for the pour point by seeing the movement of the oil. When it stops the movement, it recorded as the pour point. Now the freezing mixture, that is of taken of ice and salt, depending on how much decrease in the temperature you want. If for minus 10 degrees centigrade up to that you want to decrease the temperature, you can use ice and NaCl. The salt, NaCl and ice mixture is taken at. If we want more, minus 20 to 25 degrees centigrade, we can select the ice and calcium chloride as a freezing mixture. And if we want more, up to minus 50 degrees centigrade, the decrease in the temperature, if we want, we can use the dry ice like solid carbon dioxide. So these are the freezing mixtures which can be selected according to the lubricant, cloud and pour point, how much decrease in the cloud and pour point it is coming, or how much low cloud and pour point is there with the help of the apparatus. And it is very useful if the lubricant is having low cloud and pour point from the working temperature. The next property of the lubricant is the aniline point. What is aniline? It is the aromatic hydrocarbon, that is aromatic amine C6H5NH2. So aniline is used to measure this property called aniline point. So aniline point can be defined as the minimum temperature at which the equal volume of aniline and the lubricating oil are miscible to one another, form a single phase, that is a homogeneous phase upon mixing, and after mixing it left out for cooling. So the temperature at which the aniline and oil separates out, that is called the aniline point. So we used equal volume of aniline and lubricating oil. First we mix up, because they do not mix up at the room temperature. At the appropriate temperature should be given for their proper mixing or for obtaining the homogeneous phase. So when we get the homogeneous phase, that temperature is recorded and it left out for cooling. So the temperature at which the aniline and the oil separates out in the two different layers, that is called the aniline point. What is the significance of doing this, using this type of the aniline and making the homogeneous phase and then record the temperature at which they are separating out? Because aniline point gives the indication of the aromatic content in the lubricating oil. The aromatic content has the tendency to dissolve the rubber used in the machines. So it is very necessary to determine the aromatic content in the lubricating oil before using in the machine. Otherwise, if the percentage of the aromatic content is higher in the lubricant, it dissolves the natural rubber, it reacts with the rubber and it deteriorates the property of the lubricant used in the machine. So it is very necessary to determine the aniline point. So the lower the aniline point, greater the content of the aromatic compound. So aniline point is inversely proportional to the aromatic compounds in the oil. Lower the aniline point, greater the content. Higher the aniline point, lower the percentage of the aromatic hydrocarbon. So what is suitable? It is suitable for us to have the higher aniline point in the lubricant. Because if the lubricant is having higher aniline point, means the aromatic content is lower. Thus, aniline point is used as the indication of the deterioration of the rubber sealing. So, this is the important significance of the determination of the aniline point. Always aniline point indicate as the aromatic content or aromatic hydrocarbons present in the oil sample, and aromatic content should be low, otherwise it deteriorate the property of the lubricant, and for this the higher aniline point lubricant is desirable. The aniline point property can be determined by the apparatus called aniline point apparatus. So this is the aniline point apparatus. It consists of the two test jars. The one is the inner jar in which the electrical stirrer is attached, in which we take our oil sample, and the another is the large jar which is act as the air jacket, and it is fitted to the heating regulators. So equal volume of the aniline, that is if we are taking 5 ml of the aniline, the oil sample should also be taken as a 5 ml. And this is taken in the inner test jar. The mixture is then heated with the continuous stirring up to the homogeneous solution is obtained. So this stirring helps us to achieve the homogeneous phase between these two. So up to that temperature we should go for heating this equal volume of aniline and oil sample up to which the homogeneous phase is obtained or completely miscible to one another. After that, tube is allowed to cool at a uniform rate. The temperature at which the two phases, the oil and aniline, separates out is recorded as the aniline point. So, with the two different layers we obtained after cooling the test jar, so that temperature from the thermometer we can measure, and that will be recorded as the aniline point. So this how we can measure the aniline point, which give us the idea of the aromatic content present in the oil sample, and it should come the higher aniline point, which indicates the lower percentage of the aromatic hydrocarbon. So it is suitable to have the high aniline point. The next property of the lubricant is steam emulsion number, that is SEN. It is also called steam emulsification number. It is the time in seconds required for an emulsion of the lubricating oil and the water to separate into distinct layers at 90 degrees centigrade. So it is the time in seconds the lubricating oil separates from the water. That is recorded as SEN. In many of the applications where the lubricant which is used in the machine has the greater contact with the water, like hot strip mills, turbulence, these are the application where the machine has the greater contact with the water. So where we go for using the lubricant in these machines, it easily contact with the water and form emulsion. And when emulsion are formed, it deteriorate the property of the lubricant. So a good lubricant there is that which can easily separates out from the water. The emulsion always formed in the application, but a good lubricant should easily separates from the water. That type of the lubricant having the use in that application. So that is checked by SEN. So emulsification is the property of the oil to get mixed with the water, forming a dispersed phase of oil in water or water in oil. It can be form any kind of the emulsion like oil in water or water in oil. The emulsification property of the oil is expressed in terms of steam emulsification number, and it is determined by the American Society for Testing Material method. A good lubricant there is it can easily separate out from the water, means SEN value or the time in seconds should be low. A good lubricant should possesses low SEN. What is the significance of the steam emulsification number? Good lubricating oil has the low steam emulsification number so that when it comes in the contact with the water, it does not form an emulsion or it break out easily. It separates out from the water. That's why a good lubricating oil should have low SEN. The emulsion has the tendency to collect the dirt and dust, which reduces the lubricating property of the oil. The oil having the high steam emulsification number is preferred for the preparation of the lubrication emulsification like cutting fluids. So, which are having high steam emulsion number, it is used in the other application like cutting of the fluids and the preparation of the lubrication emulsification. But in the machine we are using the lubricant, it should possesses the low SEN. So how we determine the SEN, that is steam emulsification number or steam emulsion number. The steam of 100 degrees centigrade is bubbled through the 20 ml of the lubricating oil in a test tube. So we take the 20 ml of the standard oil sample in the test tube and we pass the steam of 100 degrees centigrade through it. So in the we pass the steam to this test tube. It is passed in the bubble form. It's when its temperature reaches to the 90 degrees centigrade of this sample. It is checked by the thermometer. When the oil temperature reaches to the 90 degrees centigrade, the time required in the seconds for the water formed due to the condensation of the steam and the oil to separate out into the two distinct layers is noted as SEN. So when we pass the steam through this 20 ml of the lubricant, as steam goes on condensing and form the water, and we have the emulsion in the test tube. So now we record the time in seconds when this oil and water separate out into two different layers, and that time in seconds is recorded as SEN. And if the SEN is low, it is a good lubricating oil to be used in the machine, and if it is high, it is having the other application. So this is all about the three properties we have read in this lecture, that is the cloud and pour point, aniline point, and steam emulsification number. So it completes whole 5 properties of the lubricant. 2 properties we have discussed in the first part of the property of the lubricant lecture, and the 3 discussed in this part. Thank you and take care.